Hi, in this video, we'll walk through how to communicate with HTTPS-based backend services in a proxy project and also how to configure load balancing for distributing requests for multiple backend services. Let's start by opening the integration.caml.yaml file to look at the initial setup. This proxy project contains two routes. Now, let's understand the configuration. In the first route, the proxy source camelid acts as the new entry point. This includes the server class name field, which clients use to send requests to this proxy project route. The incoming DDL request is converted into JSON using the convert DDL to JSON camelid, which is sent to the backend service using HTTP component. Once the response is returned, it is converted back into the appropriate DDL format with the convert JSON to DDL camelid and sent to the client. Since the backend service is listening on an HTTPS endpoint, we need to configure SSL for secure communication. The HTTP component supports SSL configuration through SSL context parameter beans. Under the component's properties, you will find the SSL context parameter field along with a helpful example. When you create a project, SSL context parameter bean template is generated automatically in the integration YAML. You just need to populate the parameters. Let's open the beans section where these configurations appear. You can edit them here or directly in the YAML file. In this demonstration, we are using the YAML approach. In the beans section, we have populated the trust store and key store details. The required fields include the trust store file path, trust store password, key store file path, and key store password. Each part depends on your environment. For passwords, you can enter them directly as plain text or use a script that prints the password to standard output. When using a script, use the format exec : followed by the complete absolute path of your script. API Gateway will parse the standard output and extract the password automatically. Once the bean is configured, you need to reference it in the HTTP component under the SSL context parameter field. Scroll to the security parameters section and enter the bean name. With this, HTTPS communication is fully enabled. Now, let's move to the second route where we configure load balancing. Here, we again start with the proxy source component and convert the incoming DDL request to JSON. Since we want to distribute requests across multiple backend services, we'll add the load balancer component from the integration patterns. On the right side panel, several load balancer types are available. For this demonstration, we are focusing on the failover load balancer. The failover strategy keeps the route highly available by always trying the first backend service in the list. If that service becomes unavailable due to an error, timeout, or network issue, the load balancer automatically moves to the next backend service. It continues this process until it finds a service that responds successfully or maximum failover attempts are completed. See the help text to understand each option before using them. We can configure properties such as round robin, sticky sessions, or maximum failover attempts. In this example, We are setting the maximum failover attempts to 5. You can set it to any number. Now, we will add the HTTP components for each backend service that will receive the load balanced request. In this demo, we configure 3 backend service endpoints. Once the load balancer is configured, the response from whichever backend succeeds is converted back into appropriate DDL type using the convert JSON to DDL camelot. To summarize, we learned how to configure SSL communication for HTTPS-based backend services and how to set up a failover load balancer to ensure high availability. These features are essential for building robust proxy projects. Thanks for watching.